Hey everybody, this is Larry. This is day 17 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest. What am I saying? Today's problem and yeah. Hope everyone's having a great weekend coming up. There's bi-weekly and the weekly contest, so you know what, I'm excited about it. And this one I always remember from the contest itself. I think we've done it a couple of times already after the contest as well. I mean, it's just it's just kind of you know, you always see Rick and Morty. The idea here is kind of, I always find it a little bit kind of weird to explain, to be honest. But the idea is really just try to figure out, okay, if I was able to, I think maybe another way to, I mean, I have a couple of videos and maybe they put it in different ways and I mean, past Larry. So this time I'm going to try to maybe a little bit funky. If it's a little bit too funky, maybe check out those videos. But I think the way that I would think about it is that, okay, let's say we are able to go to building X, right? Or like, some building I. Well, if we're going to building I, what is the best, what is the cheapest way to get to building I? And then I plus one and then so forth, right? And of course here, then you can say, I think which one is it? Yeah, and then you could, what is bricks and ladders again? You have to use, yeah, you have to use the height. Oh yeah, and then you just try to figure out, okay, if I want to use my ladders optimally, where would I put them? So basically, you ask yourself at every building, right? So that's basically the core idea of like for this problem, right? Um, and this will allow you to kind of calculate, okay, well, if I use my ladders optimally after 5 buildings, then this is how many bricks I will have left, and so forth. And the idea here then, right? And maybe you can actually do something funky as well. But the idea here is that, like, okay, as the dynamic changes and the things update, kind of, I think I mean, it is greedy, and the way that you would think about it a little bit is just by a little bit of an exchange argument, right? And I don't think that in the past I kind of didn't really go with this in detail. I'm just bringing up the drawing thingy. Hang on. I don't think I drew it in detail because I think to me, to be frank, and I don't mean this to be mean or anything or like to make fun of anyone. It's just that to me, I thought it's quote unquote obvious. But these things are always tough, right? What's obvious to me or just one person in general may not be obvious to other people, and sometimes everything is obvious to you when you see it, and everything is really hard if you don't see it, right? So I mean, it is what it is. But the idea here is some sort of exchange argument. So basically, you have to do, and we don't, let's just say we don't have, I think the way that a lot of these, like, at least the way that I explained in the past, we kind of maybe in a way jumped ahead a little bit by talking about how it evolves and stuff like that, right? And I think maybe that part is easy to kind of like just miss. But another way to think about it, like I said, is that maybe we can just say like, okay, let's say I'm able to go to this. What happened there? Hang on. Let's say we're able to go to this building, right? And we have 2 ladders. Well, then you look back and you're like, well, where can we use 2 ladders? Maybe here, and maybe here, right? Basically places where it has to. I mean, in a greedy kind of way, this makes sense, right? You're just saying, okay, well, we're gonna put the two. We have 2 ladders. We're gonna use the 2 ladders where we would otherwise have to use the most bricks because we have to save bricks just for other stuff, right? And and for the ladders, we don't use it. We just lose it anyway, right? So yeah. And then the idea here is the transition. I think a little bit, and that's the part that I think you look at the code, it's a little bit confusing because let's just say you go from here. Ooh, let me change the color. I don't know why my thing's a little funky. Hmm. Something is maybe a little bit off my drawing pad today. maybe I have to calibrate the sensitivity in my fault. But yeah, but let's say you go from here to here, and now you're faced with this height, right? Well, let's examine, right? Let's say let's the previous state here. Well, if you have one ladder to use, you'll use it here, right? But then now you're here, and then you go, well, if we could do it again, we could just change it to here. And however, the way that you would think about it is that let's just say there are many ladders in the past. You would and this is and you could do an exchange argument. You could rear the way of greedy, and then the idea here is that, okay, well, let's say you have a sum of all the ladders that you used. Which one are you gonna swap out for this new one that's biggest, right? Well, in a kind of intuitive kind of way, in a greedy kind of way, you take out the previous ladder in which is the shortest height, because then now you save even more bricks, right? So that's basically the idea that you see from a lot of these heap solutions, and that is where we're gonna go, right? I think maybe let me take a look at the constraints real quick. Yeah, I mean, I think maybe you could actually even do a binary search on, like maybe another way to solve this is do a binary search on I, right, on how far we can go, and because that would just take like O of n, maybe n log n, something like this. So it should be, or like n log square n or something like that. It should be maybe fast enough. Maybe it's a little bit slow. I don't know, but you know, but yeah. Otherwise, though, so you can play around with that idea, but the idea here is just incrementally, right? You have to basically in a greedy kind of way, you want to, if you have k ladders, you want to place the k ladder, or you want to use the k ladders on the most expensive bricks or whatever, the highest difference, the highest delta, right? And then after that, you know, it should be intuitive that you want to remove the smallest one if the new one is higher than any of those, right? So that's basically the idea. Hopefully this time I kind of explained it a little bit better. I don't know that I did, to be honest. It's I mean, we could draw out all the math and all the arithmetic, but I think that's just like, you know, I think you know, you get it. I think it should be okay. So yeah, all right, let's get into implementation. Also, well, if you're still watching this, I'm going to do an extra problem after this, so definitely stay tuned. So yeah. All right, so basically, all right, what are we doing? Okay. Okay. So we're going to do one at a time, right? So for I in range of n, maybe start from 1, so we could kind of calculate, you know, can we reach I? And basically we're going to use a heap to keep track of the max, as we said, because we just want the max. And here we want actually the min heap, because we want to remove the min efficiently, right? So yeah, which is in Python, the heap is naturally a min heap. So which is, wait, is that true? I believe that's true. Man, I get them mixed up, because in C++ and Java, I think priority is different, but I think they call it priority queue, so maybe that makes more sense in that sense. I don't know. In any case, so yeah, so if height sub I is less than height, oh, no, I minus 1, that's why. Okay, so basically we're going down. I like to write it this way a little bit, so let's do this. And if it's equal to, then we can just continue, right? We could just go to the next thing. Also, else we can just return n, because we return past forever. Otherwise, then now we want to use a ladder if we can, right? Or we want to use bricks if we, oh yeah, we want to use a ladder if we can, and h contains the max k to use ladders for. So yeah, so if if length of h, actually I guess we can just write h, we could push it in, H ladders, right? H heights of I minus heights of I minus 1, right? That's the number of bricks that we saved by using this ladder. And then while length of H is greater than ladders, then we have to, well, we don't have enough ladders, so we have to take it out, right? So we take out the min. So so X is equal to this thing, and then bricks we subtract X. Because we have to use it for that, right? And that's pretty much it. If bricks is less than 0, that means that we ran out of bricks. So this is, so I is no good, so we return I minus 1. I think that's pretty much it, unless I'm like really weird or off by 1, which maybe I am. I don't know. Oh, we don't return 4. We turn, okay. I mean, this is fine. I guess by default you don't go past the last building. Okay, fine. I mean, I just notation. All right, let's give it some minute. Hopefully I didn't make a silly mistake. And there we go. Apparently this is the 4th time already. 14, 18-day streak. And yeah, that's pretty much all I have for this one. I mean, the complexity, you know, this goes from this goes linear, number of iterations, and of course, excuse me, we push once, and really this pops at most once because this only gets incremented once. So that means that this is going to be log k, where k is the number of ladders. So this is actually O of n log k time, and of course O of k space for the h for the heap. But yeah, that's all I have for this one. Let me know what you think. Hopefully I explained it a little bit better this time. I don't know that I did. Keep on asking questions. I'll keep on trying. But yeah. I'm going to do a random problem after this, so stay tuned, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Also, like, if you have Rick and Morty, wouldn't they just like use a portal gun and not use a ladder? I don't know. Anyway, bye bye.